Thank you everyone for joining us today for talking about streaming data into Snowflake. I think it's going to be a really great conversation we're going to have, and I'm really lucky to be joined by John McKinnon, who's one of our engineers who helped write the integration with the Snowflake Snowpipe streaming API. So John, welcome. It's good to have you here. We're going to talk about streaming data into Snowflake and how this new API and the integration with Decodable can dramatically reduce costs and complexity in setting up streaming data into Snowflake. Before we get started here, we're going to try and answer questions as we go, but that's not always possible. But the way that you can send them to us is by entering them into the Q&A field in the platform. So please do that. Like I said, we'll try and answer them as we go. Any we don't get to, we will answer at the end of this session. So let us know if you've got questions, you want to talk about any specifics. We are here to answer them for you, for sure. This is a webinar that's for you and to get you the information that you need or any information that can help. So with that, we're at about 3 minutes after the hour. I think it's time for us to get started. And let's talk about streaming data into Snowflake. So just to level set at the beginning, the future of data is really becoming a real-time activity. There's a lot of use cases for real-time data that I think are very important. Our industries in general are beginning to use real-time data in very meaningful ways. The shorthand I use is this. If you've been in data for a while, you can think of a number of use cases where stale data can break what you're trying to accomplish. Maybe you can't get product recommendations in front of people in time. Maybe you have stale supply chain data and you don't know where your inventory is. There's a lot of reasons why it would be hard to have stale data, but there's, to date, I can't find any use cases where the freshest, most accurate data is really going to hurt you. And so people are moving increasingly towards real-time data, and with the understanding that when data is late or when data is latent, sometimes it's just too late. Now, I don't want to belabor that point, but it's particularly important when we're building this rise of real-time data applications that are not just traditional analytics workflows or traditional analytics pipelines. We're talking about applications that are actively consuming data right as it arrives. So to that end, I think we have a poll question that would be really interesting for people to answer. So I encourage you to do that. Are you using real-time technology? And really, if you are, which ones of these are you using? It'd be great to hear from you as we go. So I'll give you just a few minutes to answer that one, and then we'll take a second and see what our choices are. All right, I think we probably know enough there to close this poll. I apologize for moving pretty quickly here, but maybe what we should do is go on to the next slide and then take a look at the answers there as we go. So in addition to, oh, look, there they are. Fantastic, right? So yeah, we're looking at people using Flink and Kafka and Spark streaming and some other stuff. And if you've got questions about things which we don't have on there, or you want to know it, you want us to know it, you can put it right into the Q&A field. We'd be interested in hearing your thoughts there as well, or you can chat it directly to us through that same mechanism too, if that's available to you. But yeah, so good. Flink and Kafka are increasingly popular. What else is increasingly popular in this space is Snowflake. And Snowflake is increasing in adoption in general. But what I think is really interesting is the increase in adoption for application developers, for people who are building these real-time data apps. And there's a few reasons why Snowflake is so popular. It's nice and scalable, right? It's essentially as big or as fast as you need it to be. It's got a lot of built-in tooling to help you with that workflow of sort of build, test, and prod kind of an environment. And it's fully managed, which I think is incredibly important here. In a lot of our data stacks, we have a tendency to rely on a set of complex components, which can make the management and ongoing operations of those data stacks challenging. So Snowflake is fully managed, so you get all this stuff sort of effectively with the swipe of the credit card, all capable for you to do, for an application developer to focus on the application instead of on the infrastructure. So Snowflake is growing in adoption, and so I think we have a poll on this one as well too, so you can see that. For those of you who aren't familiar with it, in the streaming environment, we tend to think of data as coming from a source and going to a destination. We call that destination a sink. And so we'd be really interested in knowing what types of sinks you're using. Where are you sending streaming data in your environment? We assume you're using Snowflake because you're on this particular presentation, but you might be using other things like Delta Lake and Databricks, or Pinot or Cassandra, something from Startree, or several other things. So we'd love to hear from you on that one. I'll give you a second to answer that. Thank you for being interactive with us and answering these polls as we go. All right. Look, a lot of people are syncing into Databricks. Interesting. Or I'm sorry, we've got a couple of votes there for Databricks and one for another. Excellent. Thank you. All right. So let's get to the meat of this a little bit, and I promise we'll get you to John in the real technical demonstration of this as we go. But let's talk about how we've been moving data into Snowflake, streaming data into Snowflake up until roughly this point. Essentially, streaming data into Snowflake has been a two-step process. With the first step, you stream into Amazon S3 into a bucket, and then you have to pick it up out of that bucket in batches and bring it into Snowflake. So there's a couple of things that add to that complexity. So this idea of ingest from S3 into Snowflake is called Snowpipe, and that is done when Snowpipe is triggered to pull the data as S3 into Snowflake. And so if you're trying to do minimally latent data in this old architecture, what you need to do is alert Snowflake to trigger Snowpipe to ingest the data from S3 based on the data arriving in S3. And so you use a system like Amazon SQS to tell Snowflake to do this batch ingestion. And there's some complexity involved there. You end up with multiple systems, you end up with latency, and that ingestion into Snowflake can be pretty costly. Typically, people who are then doing this are then, of course, connecting from Snowflake into the apps and microservices. But if you're relying on the data to be delivered right into Snowflake, and you've got this latency and brittleness between S3 and Snowflake, sometimes you're going to get just reduced performance on the app side. And if the app's in front of users, your users are going to see maybe delays, maybe old data, maybe sometimes it doesn't work the way you expect it to. It's not a bad architecture, but what it is somewhat unnecessarily complex. And so that's the way that we've been doing it up till this date. I think we have even another poll at the end of this particular slide as well, to talk about what type of cloud you're using. So this is kind of important, right? Snowpipe works really great with S3, but we'd be interested in hearing, are you in AWS as your primary cloud? Are you in Azure? Are you using multiple ones? That would be interesting to hear. So a couple of quick clicks from you on that, and then let's take a look at those results. We are whipping through these polls quickly, so thank you everyone for your patience as we go. All right. Interesting. So we're seeing a decent amount of Azure. That's super important and super interesting. And then, of course, there are a few in several clouds as well. We do increasingly see people in multiple clouds. That's a trend we're seeing as well. And we're seeing a lot of people who are looking at the cost benefits of putting everything in the cloud versus repatriating from cloud. And it can be pretty complex to do that pricing analogy. So with that being said, let me share with you the new way to get data into Snowflake. And I think we're pretty interested and excited about this as an industry. So this is introducing the Snowflake Snowpipe streaming API. This is obviously, this is not a decodable feature. This is a Snowflake feature. And it's currently in technology preview from Snowflake. It is, if you have Snowflake currently available in your account now, it should be enabled already, but if it's not, talk to your account rep. But this API allows you to stream from a streaming system right into Snowflake and make those changes into a table, into a schema in Snowflake right away using the API. So what we're eliminating is the batch process or the batched job of moving into Snowflake and removing the need to do this third communication channel to make sure that Snowflake knows the data is available. With the Snowpipe streaming API, the data is directly right into Snowflake, which is super interesting. In an architecture like this, that doesn't mean you're ignoring S3. You can still, if let's say you're streaming with Kafka, you can still stream that right into S3, right? Or you can stream directly into an app or a microservice so they have that information. But if you're going to be streaming directly into an app, you'll probably want to be doing some type of transformation on the data beforehand. That's where a stream processing platform like Decodable comes in. But this is a much simpler architecture. It's a lot less reliant on a single dependency, which is a batch dependency of the old Snowpipe mechanism for moving data into Snowflake. So when do you use the new Snowpipe streaming API, and when should you use sort of the old architecture of streaming right into S3? I think Snowflake, and I'm speaking as a Decodable person, not a Snowflake person, obviously, but I think Snowflake's expectation is most people are going to be moving to this API. And their claims are that it is much cheaper and results in much lower latency data in the Snowflake tables. So those claims are, as far as we can tell, having played with this for a while and having built, or John built the connector and seen it in action, is that those claims are absolutely true. We had to check our Snowflake bill to make sure they were actually charging us. That's how much lower the price of moving data into Snowflake was for us. And the data is arriving, within milliseconds of latency. And so that's pretty great as far as we can tell as well. Now, your mileage may vary, and be aware that it is still as a technology preview from Snowflake. So we don't know the final outcomes for this, but it is extremely promising. And I think that this architecture, which simplifies putting the data into Snowflake, and then your ability to stream right into an app or right into S3 is sort of separate from that, is really the right architecture going forward. And we think that people will adopt it pretty extensively. Do we have a poll for this one as well? I think we may. Yeah, so we'd love to hear a little bit, and I think the other attendees would love to hear a little bit about your use case in streaming data. We have a few different use cases that we've seen that we've put here, but if it's not there, feel free to ask a question in the Q&A field. We'd love to find out what you're thinking about as your use cases for streaming data, what challenges you might have in streaming today. Let's certainly chat through that. And based on those results, we might ask some questions of myself or John as we get towards the end of this. While you're answering that, let me remind you that we do have the Q&A. So if you've got questions, please put them in there. We'd be happy to answer them towards the end of the session as well. All right, let's see what those results are. Okay, interesting. Financial data coming in and customer data as well. Very, very interesting. And merging stream processing and batch processing workloads. Very, very interesting. So thank you for that. This particular presentation isn't really about it, but one thing that Decodable can do, or that we do have, is an adapter for DBT. So if you've got your batch processing logic stored in DBT and you're processing, batch using Snowflake or another database, you can use that same logic in a stream processing context with Decodable, which is based on Apache Flink. So you can store that same SQL logic to use either for batch or for streaming. And with minimal modifications, you can use the same logic in both places. And it makes the transfer of that, the business logic that you're using for that transformation in batch super easy into a streaming context. So that might be something for those of you who are doing that to look into. And if you're interested, that makes a ton of sense for some of you people. Now, we do have a question right now that's coming in anonymously. So let me take a second to answer it right now, John. And if you want to weigh in on this, you can too. But this is a question about streaming into a warehouse because it's so expensive to hold all of my raw events. I think that's a really good point for this architecture. If you're streaming into Snowflake, Snowflake might be an expensive place to hold all your raw events, depending on the volume of those raw events, but for sure. And so with a tool like Decodable, a stream processing platform like Decodable, what you can do is a few things. You can pass through raw events into an S3 bucket or someplace that's cheap and deep to store them as raw events. But because Decodable actually does transformation of data in flight on its way, you can store aggregates. You can push aggregates via the Snowpipe API into Snowflake instead of pushing that raw data in. And in fact, John is going to show you that in action in just a little bit, aren't you, John? So we'll show you how that works. But that's the way you solve that problem. You want to store all the raw events, but you probably only want to put some type of aggregate into something expensive like an enterprise data warehouse. And then what you send to apps or microservices or to messaging systems might be filtered, might be joined sets, might be aggregated sets. And so that's the point of doing the stream processing in a tool like Decodable, because then you can sort of decide what granularity, what level of aggregation, what level of normalization goes to what destination. And so that's how that works here. So thank you so much for the question. And again, ask your questions away. We'll answer them as we go. Any that we have left over, we'll get to at the end. So look, this is sort of a Decodable presentation. So I do want to give you just a few seconds about what we do. If you look at what sits under the covers of stream processing, you end up with things like Flink or Spark Streaming, Kafka, Pulsar, Kinesis. You need connectors from those into both sources of data and sinks where the data is going. You need something that can handle change data. You need to run that all in some infrastructure, probably in Kubernetes. It's complex. And so what Decodable is at its core is software as a service where we manage all of those components together. And you fundamentally have to define roughly three basic things: where the data is coming from, where you want it to go, and the transformations in the middle. So if you're developing a microservice or you're really interested on how it's being consumed, you can build that processing pipeline in just a few minutes. All it takes is SQL. It's really easy. You don't have to manage all that open source. You really just have to define source, sink, and transform. And fundamentally, we're trying to make the part of managing streaming kind of boring for you, because it should just work and you should be able to focus on using the data rather than spending all your time setting it up. So speaking of setting it up, let's go right into seeing it in action. So John, if you're ready, what I'm going to do is stop sharing my screen for the attendees here, and we'll switch over to you showing us how this works as we go through it. Does that make sense?
Yeah. Right. Okay, so today we are going to demo the decodable connectors, the sync for Snowflake, and show just how fast and easy it is to get real-time data sent to your Snowflake tables. I'm going to start by creating some bogus data that we can send to Snowflake. So you'll see here I created a new connection in Decodable. I'm going to scroll down to the data gen. This is a source. It generates bogus data that looks like web traffic. It's configured to make 10 events per second. So let's go ahead and see what that looks like. I'm going to create an output stream to send that data to, and this will be Snowflake demo raw input. And the schema of that will be one single field that we'll call envoy event, and it'll be type string. We'll call the source generator the Snowflake demo input generator. And we'll go ahead and create that connection. Okay, so now we have this connection. I'm going to start it. And this is going to generate data here very shortly. You'll see that's up and running now. If I look at the stream it's outputting data into, we can look at what that data looks like. You'll see here we just have this kind of append-only log of immutable event data. It's got a timestamp. It's got a like a bogus request method, and then a path that is acting against, as well as a user agent. And so now we've got data generating into Decodable. Let's go ahead and get that put into Snowflake. The first thing I want to do I'm going to come over here to Snowflake. I want to create a landing space for that, a table where all that data is going to end up. Starting from scratch here, I want to show you, I'm going to use user John McKinnon for this. That's my personal account. Coming down here, you'll see I have an RSA public key. This was already set by me prior to this demo. We have directions on how to create a public-private key pair. That's how we authenticate from Decodable to Snowflake. That's in our documentation for the connector, but in order to make things run a little faster today, I've already generated that. I'm going to create a new role that I'll use as kind of a service account for Decodable. We'll call that demo role. And then I'm going to grant access to that role to my user. So that's all fine and good. Now let's create a table for this data to land into. I'm going to call that table Envoy Event Ingestion. It's going to have a single column called Envoy Event. Notice that that matches the schema here. It is also a string. And then in order for Decodable to send data to that, I need to make sure that the role that we're using, this kind of service account role, has insertion permissions on the new table. Great. So let's go back over here to Decodable on the left, and I'm looking at my stream of data that's updating in real time as data flows in from that generator. I'm going to create a sync connection, which is going to send the data to Snowflake. So we'll scroll down here to Snowflake, and we'll hit connect. Now I need to configure this to match kind of what I built here in Snowflake. I'm using John test database and test schema. So I'll go ahead and put those in here. The table is called Envoy Event Ingestion. The user, this is my personal user again, John McKinnon. The private key I'm going to copy from off screen. The role is going to be the new role I just created, demo role. And the account name, I'll show you how we find that from this main page in Snowflake. Go down here to the bottom. Come over here to the account. We'll click on that. And that gives us the account ID as well as the organization. So we gotta replace that period with a dash. So it's organization dash account. And then these last two fields are only relevant for change streams. We are working right now with an append stream, which is immutable data. We don't need to worry about these last two fields. I'll show them later. And we're ready to go. So we'll hit next. This is going to confirm that all my info is correct. Looks like it is. And then I need to select the stream that the data is going to come from that's being put into the sink. So we'll select Snowflake demo raw input. That's what we just created with that source. It inherits the same schema from that data source. So Envoy event as a string. I'm going to call this connection Snowflake demo append sync. We'll call it raw sync. We'll create the connection. So now we've created it. We'll go ahead and hit start, and I'm going to go from the earliest point, which means that we'll pick up all the data that's been accumulating in that stream. And now you'll notice, so over here on the right, I've got my queries to check data that's coming into the table. The first is just a select star from that new table. That's empty right now because this is currently starting up. The sync isn't running yet. And then there's a count star of total events and then count distinct to find the number of unique events. And we'll see that those numbers stay in sync and also gives us an idea of as data is rolling in. So data is going to be accumulating in this stream over here in Decodable. We'll see the sync catches up nearly instantaneously, and then it stays up to date as more data rolls in. So we just give this a few more seconds here to start up, and then we'll see the input metrics, we'll see the output metrics, all of that will start. We'll see numbers go up there as data is flowing through. All right, so we are running. Let's see, we've got input metrics, we've got total records. So if I select, I've now got event data coming in over here into the table. I'm limiting the number of events that are returned, but this should give you an idea that new data is constantly flowing in. So let's look at the counts. We'll see 3,151 events. that many unique events. If we run the query again, it's now 3,300. So you'll see it's updating in real time as data flows into that stream. 3,400 and so on and so forth. So that's append data. That's how easy it is to create a sink in Decodable to get your data from Decodable into Snowflake. Now, maybe you want to do something a little different. Maybe you want to mirror data from a database that has primary keys, like a MySQL database or Postgres, maybe, or maybe you want to perform some kind of aggregation on this event data inside of Decodable and then send that data to Snowflake. In all these cases, you're dealing with a primary key that has updating values as opposed to immutable data that doesn't change. So let me go ahead and create that in Decodable, and then I'll show you how we can send that to Snowflake. Going back to this raw input, we've got the sink here. Rather than creating a direct sync, I'm going to create a pipeline which works in parallel to the existing sync. And this is going to generate kind of an offshoot of the data that has a transformation. And that transformation is expressed as SQL. I'm going to go ahead and paste this in here in the interest of time. And so what we're going to do is we are going to select data from our input stream, which we called, look at Snowflake demo envoy logs. Oh, demo raw input. We're going to select from that stream. We're going to use this tool called Grok. What that does is it parses out this field envoy event, which is the bogus request event. It's going to strip the timestamp out, and it's going to take the method, that next little chunk of data, and it's going to call it method. So we're selecting that. And then from there, we are going to cast method as a string, and then we are going to group on that method and then get the total count for that method. So what that looks like is it's going to be the action taken, the put, the get, the update, and then the path. And then that combination, how many of those are we seeing? It's going to sum them up and count all the unique different permutations we see. So we want to insert that into a new stream. So we'll call that one Snowflake demo aggregated input. And if I want to run that preview, this is going to run my SQL over data that's coming in, and we'll see kind of how that shows up. So we see the method, and then we see the count, and it'll continue to tick up on the count as more records flow through. Great. So that looks good to me. I'm going to go ahead and say, yep, it's going to create a new output stream for me. The name's inferred, the schema is inferred to match the SQL. I'll go ahead and create the stream. And then now I want to create this pipeline. I'll call it Snowflake demo aggregator. Now we're going to get that running. We're going to start at the earliest so we can take all of the data that's already been generated. And then that is going into this output stream, which we want to then sync into Snowflake. So let's cut over here to the right again to our Snowflake worksheet. And I'm going to want to create a new table that collects this aggregated data. And so we have this schema where we have method, which is a string, and then count, which is a big integer. So we're going to map that over to our table here, which we're calling envoy event aggregated. We've got method, we've got count. And then I need to, since I'm processing change data here where the value updates, we need to add a few more permissions for the role in order to update the table as those updates roll in. I'm going to not grant enough permissions just to show what that looks like during creation, but we will need select, update, and delete. Right now I'm just granting insert, and I'm going to grant create table in the schema as well. So if I select star from the new table, no records, that makes sense. We don't have a sync yet. And then if I try and get the total number of rows and the number of unique methods, again, no data. So let's check out that pipeline. It should be done here pretty soon. while that's starting up, we can go ahead and actually get started on creating a sink. So this will be creating a Snowflake sink. Again, this will be very similar to the append sink where we do John test DB, test schema, table name, envoy event aggregated. User is John McKinnon. Private key, I'm going to copy into there again, and I just paste that directly in. Role is going to be demo role. Count name is going to be this name down here. And then the materialization interval, go ahead and say every 15 seconds. We want to see that materialized. And then the warehouse, we use the same warehouse to run this materialization that I'm using for my queries. So it'll be John test extra small. And so I want to take the data from the aggregated input. We'll see that we inherit the same schema. And then I'm going to call this connection Snowflake aggregated sync, demo aggregated. Go ahead and create that connection. Okay, and so we'll see this error message pop up. It tells me that my role lacks the sufficient permissions to interact with this table we created. We need to grant select, delete, update, and insert. That's what we expected to see. So I'm going to go over here and I'm going to grant those. Great. And now I'm going to try and create the connection again. And it should allow me to this time. Check that out. And I'm going to go ahead and start this up again from the earliest so that we make sure we get all the data. And I'll get that running. In the meantime, we'll see that the pipeline, which is this aggregator that has the SQL, that has started running. And we can look at the data that it's outputting. And we'll see these are the counts that we've witnessed so far from all the data that's been generated up until now. Where you've got the method and then the count. So one note about this sync, when you are running CDC data, Snowflake is clearly an OLAP database. It doesn't support primary keys in the traditional sense. And so updates are not performed in the same way that you might with, say, like a Postgres table where you can just update a value. We have to perform those with merge queries, where we are syncing all of our change stream data into a temporary staging table. And then Decodable is running that merge step for you. And this is what that change stream materialization interval controls, is how frequently do you want to merge that data into your destination table. But Decodable takes care of all this for you. But that is an extra step that it's kind of unavoidable since Snowflake isn't designed around primary keys. And the warehouse that you select is the one that's used to perform those merges. So we'll see here we have it running, which means that it is flowing data into our aggregated sync. If I select, then I'm seeing now we've got the results popping up here where we've got the method and count. I'm selecting by the highest count, top 5. And let me show you the counts here. So just to prove that we are indeed respecting those primary keys, the total number of records in that table, that aggregated table, is equal to the unique number of methods that we see. So for each primary key, you'll only find one instance in this aggregated table. Now, if we go ahead and come back here, we'll see the top records are 239, 238, 237. If we keep running this, eventually we will see those shift. This is all random, so we can't for sure say that it's going to happen within a few seconds because the input data is random. But you'll see that it is updating in real time, right? So now we've got 246, 245, 244. So the data is coming in, it's seeing that it's incrementing and it's changing that in our downstream table. And that's it. That's Snowflake syncs. You've seen how to take data that is append-only and sync that into a Snowflake table in real time. You've seen how data that has an updating value for a primary key, that's change stream data, how that can get sunk into a Snowflake table. in near real time. I say near real time because you ultimately control that with the materialization interval as a user. But that's it. Easy, simple, and you've got data flowing into your Snowflake.
So John, thank you for that. Let me share just one last thing here as we go for those of you who are on, and thank you for your patience. If you want to walk through this again, see that part a little bit more fully, we're happy to do that. All you have to do is go to decodable.co, request a demo. We'll have someone reach out to you and see what your needs are. We can figure out how we can get you the information that you require. I want to say thank you for everyone who asked questions. Hopefully we got to most of them as we went. But if there are any that were outstanding, and I'll check that, we will reach out to you afterwards with answers to those questions. So again, thanks for asking them. And we appreciate you taking the time with Decodable today. Go to decodable.co, request a demo, and hopefully we'll get a chance to talk to you again soon. Thank you so much. And John, thank you as well, of course, for everyone else.
Anytime.